This is a video that's going to help you review for our quiz on statistics. Go ahead and, if you're in my class, turn to page 46 and complete the warm-up. You should pause the video while you complete the warm-up. Okay, hopefully you've tried this on your own. So the scores for Josh and Matt's classes on the progress check were normally distributed. When they compare their score to their respective classes, Josh and Matt had the same Z-score. They both scored a 83. Matt's class had an average of 77 and a standard deviation, or depending on which symbol we're using, of 4. Josh's class had a standard deviation of 2. Okay. What is the average score for Josh's class? So this is for Matt. So for Matt, he scored an 83 minus the average of a 77 over a standard deviation of 4. So if we go 83 minus 77 divided by 4, we get a standard deviation of, a Z-score of 1.5. Now this is going to be the same as Josh's. So Josh, we know, also has a Z-score of 1.5. We know he scored an 83. And we know he's got a standard deviation of 2, so minus the average. So here we go. If we multiply both sides of our equation by 2, we get 83 minus the average equals 3. And so that tells me that the average for Josh's class was an 80. Okay, so let's go ahead. You should try the review sheet. If there is a number 3, I don't remember how I sent it to the printer, but if you have this problem, Jake took 10 quizzes, you can cross that problem out. Again, you should try this and then use the video as a resource. So SAT scores are normally distributed with a mean of 400 and a standard deviation of 25. Label the mean values that are values that are 1. So here we go. We've got 400 in the middle. That's the mean. 425, 450, 475, 375, 350, 325. We know that from here to here is approximately 68%. We know between -2 and 2 standard deviations is approximately 95%. And we know from -3 to +3 standard deviations should be 99.7%. Letter C asks what percent of students scored above 275. So if I'm looking at my graph, I see that we're talking about this area from here up. Now I know from here at 0 at 400 up, this is 50%. And I know between these two red lines is half of 68. So this is going to be 34%. So it's going to be approximately 84%. Explain how you arrived at your answer. I'm not going to write it out in words, but I just added, well, I could just go 34 plus 50, less than a 450. So a 450 is going to be here at this green line. Again, I can just add up the sections, or what I can do, which might be a little faster, is I can find these 2 sections and subtract from 100. If between +3 and -3 is 99.7, I know that I've got 0.3% left. So I know that this is 0.15 and this is 0.15. If it's 95% within 2, I know that, oh, actually, I don't need the point. I could just go with that. I'm gonna wait, let me get rid of 0.5. Okay, so if I know that it's 95% plus and minus 2 standard deviations, that means I have 5% for this area and 5% for this area, which means this is 2.5% and 2.5% to add up to 100. And now for 450, I'm just going to go 100 minus, because it's less than. So I'm going to go 100% minus that 2.5% gives me 97.5%. What percent of students are between 350 and 475? So here is 350. Here is 475. So I'm going to go, I know between 350 and 450 is 95%. And then now this little area here that I'm marking with black, I'm going to use that fact that I talked about before and ended up not using, that I know that this area is 0.15. I know that this is 2.5. So I know that this area will be 2.35. So I'm going to go plus 2.35 gives me 97.35%. Joe scores higher than 84% of the students who take the test. So Joe is scoring higher than 84%. So what score is Joe at? So if he scored a 400, Joe would be smarter than 50%, but he's smarter than 84%. I know that this area between 0 and 1 standard deviations is 34%. So if I do 50, so right here, if I go to 0, that's 50%. And then I go here, this is 34%. Joe scored a 425 if he scores higher than 84%. All right, number 2, suppose the IQs of East State universities are normally distributed with a mean of 125 and a standard deviation of 10 points. West State also has normally distributed IQs with an average of 125 and a standard deviation of 8. So Lisa, so we're basically looking for, as I read this question, we're looking for the Z-score. So Lisa is going to be 125 or 124. She's from East State, so 135 over 10. And when I do that arithmetic on my calculator, I end up with negative 1.1 for Lisa. Now for Joe, a little bit. For Joe, Joe is 131 minus 135 over 10. So Joe has a Z-score of negative 0.4. Mike is 124 minus 125 over 8. Because remember, our formula is Z equals data point minus the average over the standard deviation. So for Mike, I get negative 0.125. For Cindy, I have 118 minus 125 over 8. And Cindy has a Z-score of negative 8. Now let's see how we want this to be ranked. Lowest to highest in terms of success. Well, the lowest high, so I'm going to make the low, this is 4th place, this is 1st place, the highest. So lowest ranking is going to be Lisa, and then Cindy, and then Joe, and then Mike. Okay, draw a sketch of a normal curve with a mean of 10 and a standard deviation. Then draw a mean of 10 and a standard. So I'm going to put this on the same grid. I can make this pop up. Come on. So, oh, well, that's okay. So here's my grid. And here's 10. My first has, so notice I've got a standard deviation of 2 and 4. So this is going to be 12, 14, 16, and then it's going to be 8, 6, 4. Now, this problem has a smaller standard deviation. It's going to have the same 100% of data under it, so it's going to need to be taller. This has a larger standard deviation, but it's got the same data, so it's going to be more spread out. It's going to be a shorter. So let me see how good I am at curve drawing. My goal, I'm going to put it here first. So this is like, here's my goals here. Let's see how good of an artist I am. Oh, it's fair. Okay, so now I'm going to switch to blue and mean, so 10, here's the first standard deviation. Here's the second. Oops, that's a little wide. And the third will be here. So 1, so here's the mean for both. For now it's 1, 2, that's 20, and then 22, 3 standard deviations. And so now 4 on this side is going to be -1, 2 is -2, 0, -2 is -3 standard deviations. So now I'm going to make the curve is going to be lower. So I'm going to try to aim it. Let's see how this goes. This might not be the most beautiful graph. Oh, that's pretty ugly. Oh, geez, we can't have that. We need some goals. Let's try to get it like, I don't know. Let's try it. I had better success drawing it this way. Okay, well, it's not pretty, but you get the idea. Wow, that is so ugly. The curve just needs to be shorter because it's more spread out. Cool. Okay. Draw a sketch of a normal curve with an average of 3 and a standard deviation of 1. And now we're going to have the same standard deviation, but a different mean. So because of this, I know I'm going to have the same shape because we have the same spread. Standard deviation is a measure of spread. How much does the data deviate from the average? Well, they deviate the same amount. The difference is here we've got a mean of 3 versus a mean of 6. So I'm going to draw my number line. I'll do this one in blue. We have a mean of 3. So I'm going to go 1, 2, 3. Here's my mean. 1, 2. This is going to be 2, 1. That'll be 3 standard deviations down. This is going to be 4, 5, 6, and 3 standard deviations up. I'm going to put my curve here. I'm going to do my best. It's not going to be pretty. That's okay. Oh, damn. Oh, that's ugly. And I'll do the other one in red. Now, the only difference here is that the average is different. So it's going to have the same peak. 1, 2, 3. 1, 2, 3, 7, 8. This is 9. So the only difference is that the whole curve is the same shape. It's just higher up on the axis. So 3 features of a normal curve. One feature is they have a single mode. They are symmetrical. We could say that the mean, the median, and the mode are all equal. And those are probably the 3 best. I mean, there's lots of other things you could say about them in terms of the mean and standard deviations, but these are the 3 general. Again, you should be pausing the video and trying these problems on your own and then using the video to check, or if you need assistance, use it for assistance. Some business analysts estimate the length of time people work at a job has a mean of 4.2 years and a standard deviation of 2.5 years. The person is selected at random. What is the probability they will work 2 years or less? So I'm looking for less than this. So real quick, I'm going to go 2 minus the mean. Whoops. So I need to find the z value. How many z-scores are we away from the mean? Divided by 2.5. I'm going to toss that into my calculator. And I get -0.88. So I know if I was looking at my curve, I know I'm like here, negative 0.88, and I'm over here. And I do this because it just gives me an idea that I am less, like it should be a small value. So I'm looking for the probability that Z is less than negative, ooh, that's not good. Now I'm going to use my tables for this. Let's see if I have one loaded. Oh, I do. Hooray. All right. So negative 0.88. Oh, look at that. So here's negative 0.8. And I know this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So 19 or 18.94%. Again, let me make it a little bigger. So again, I'm looking at on my table, negative 0.8 and 0.08. And I can just use that number because it is less than. Oop. Okay. And then for the last problem, businesses are going to give a bonus to people who work the longest 10%. So what I'm going to do is, again, I just need a visual here. So the people who work the longest 10%, that's going to be like here. Like this is 10%. Okay. Well, I shouldn't put that there. This is 10%. So I know that this percent is 90% because it has to add up to 100%. So what I'm wondering is, what is the Z value here? So I'm not going to look at Z value for 10% because that's going to be the number here. I'm going to look for Z value in my table for 90%. So I'm going to go to my table. These guys, I want to be over here because I know that it's a positive Z value. All right, let's see if we can find it. So 90%, 80, I think okay, so here, these two are the closest right here. And this one is definitely closer to 90%. So I'm going to go with 1.28 as my Z value. Okay, so I looked in the table. It's a little bit of a needle in a haystack situation for 90%. So I'm going to say, I forgot what it was. 1.28, 1.28. So I know my Z is 1.28. So now I can say 1.28 Z equals X. That's what I'm looking for. How many years you need to work minus of average of 4.2 divided by a standard deviation of 2.5. And I'm going to use a little algebra. I'm going to grab my calculator. I'm going to multiply both sides. 1.228 times 2.5. And then I would add the 4.2. And I get an answer of 7.4 years. Quiz tomorrow. I hope this was helpful. The answers are posted in our shared Google Drive.